let's just move on further towards the question number 4, which says that prove that the opposite sides of a quadrilateral circumscribing a circle subtend a supplementary angle that is nothing but 180 degree at the center of a circle. So let us suppose if I'm just taking the figure for this particular question, that I am taking a quadrilateral circumscribing a circle in such a manner, and I already did a little bit of construction over here, that wherever the circle is intersecting this particular quadrilateral, I'm just calling them as the point as P, Q, R, S, and I am joining them with the center of the circle. So this is my construction that I did. First of all, I have drawn a quadrilateral, then a circle inside of it, and wherever the circle is intersecting this the quadrilateral, I'm just calling those points as P, Q, R, S, and I've already joined the P, Q, R, S points with the center of the circle in such a manner. Now I just have to prove that the opposite sides or the quadrilateral circumscribing a circle subtend a supplementary angle at the center. Means what we have to prove, let us suppose if I'm writing just over here that we have to prove that the angle AOD plus angle COD is nothing but is equal to 180 degree, and furthermore we have to prove that the angle AOD plus angle BOC is nothing but 180 degree. So we just have to prove this particular fact that they are making an angle of 180 degree. But before that, let us suppose if I'm just taking these angles as nothing but angle 1, I'm just taking this as angle 2, I'm just taking this as angle 3, and furthermore I'm just taking this angle as nothing but angle 4, this angle as nothing but angle 5, this is my angle 5, this angle as angle 6, this angle as angle 7, and furthermore I'm just taking this angle as nothing but angle 8. So I'm just taking these angles as angle 1, angle 2, angle 3, 4, 5, 6, 7, 8, and so goes on. So let's just talk about the proof of this particular question. So first of all, I'm just taking two triangles over here. So I'm just talking about in the triangle APO and triangle ASO. So I'm just taking two triangles over here. First of all is APO and the second one is ASO. So since A is an external point, always remember from an external point, the length of the tangents are always equal. So in these two triangles, first of all, we can say AP is nothing but is equal to AS. We know about this particular fact that the lengths of the tangents are always equal. The lengths of the tangents are equal always. They are equal always. So we can say about this particular fact. Now furthermore, we can know that OA is nothing but is equal to OA. This is nothing but the common side. This is nothing but the common side. Furthermore, we know about this fact that OS is actually nothing but is equal to OP. Why? So being the radii of this circle, we can say about this fact. So hence from the SSS congruence criteria, we can say that these two triangles are actually these two triangles are actually congruent to each other by SSS congruence criteria. We can say about this fact that these two triangles are actually congruent to each other, and since if they are congruent to each other, then by CPCT we know that angle 1 is equal to angle 8. We can say about this fact by CPCT we can say that angle 1 is equal to angle 8. So actually we have proved that in these two particular triangles, these two triangles are actually congruent to each other, which are actually made from this particular external point, and these triangles are congruent, which implies these two angles are equal to each other. And similarly we can say about these two angles, similarly we can say about these two angles, similarly we can say about these two angles are equal to each other. So let us suppose if I'm just taking a similar concept. So similarly we can prove that angle 2 is equal to angle 3. We can prove that angle 4 is equal to angle 5, and furthermore we can prove that angle 6 is equal to angle 7. In the same manner like we did for these two triangles, we can prove for the other triangles as well. So I'm just writing it over here in the similar manner. We can proceed further, and now I'm just taking a sum of all these equations. So let's just add 1, 2, 2, 3, 4 all together. So we can see over here that it is nothing but since we know that angle 1 is equal to angle 8, angle 2 is equal to angle 3, angle 4 is equal to angle 5, angle 6 is equal to angle 7. Now rather than adding them up, let us suppose if I'm just talking about the linear pairs. And now I am just taking the sum of all the angles with respect to this particular central point O. Since we know about this particular fact, the sum of all these angles around this particular point O at the center of the circle is actually making an angle of 360 degree. So it implies that angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus of angle 8 is actually nothing but is equal to 360 degree. We know about this concept that the sum of the angle at the center of the circle is nothing but a whole 360 degree angle. So using that particular concept, I'm just writing it as this. Now further we know that angle 1 is actually nothing but is equal to angle 8. So since as you can see, we know about this concept that angle 1 is actually nothing but is equal to the angle 8. Furthermore, we know that angle 2 is equal to angle 3. Further, we know that angle 4 is equal to angle 5, angle 6 is equal to angle 7. So what we wanted to prove over here, we just have to prove these two things, that angle AOB, and the angle COD's sum is nothing but is equal to 180 degree. So let us suppose in place of angle 8, I'm just writing angle 1. So hence it implies that let us suppose if I'm just writing as angle 1 plus angle 2 plus in place of angle 3 we have this particular angle that is nothing but angle 3, which is actually is equal to the angle 2. Actually the angle 2 is nothing but is equal to the angle 3. So it implies in place of angle 3 we can write angle 2. So I am just writing angle 3 as nothing but is equal to the angle 2 from the equation number 4 second. And furthermore, we know that angle 4 is equal to the angle 5. So in place of angle 4 we can write angle 5 plus angle 5 plus of angle 6 we have, and furthermore we can write angle 7 as nothing but is equal to the angle 6. So this is nothing but angle 6 using the equation number 4 plus of angle 1, which is equal to 360 degree. Again using the equation number 1, 2, 3 and 4. I'm just writing this particular concept. Now you can see over here, if I'm just taking these two angles, angle 1 and angle 1, so we have 2 angle 1, we have 2 angle 2, we have 2 angle 5, we have 2 angle 6, which is nothing but is equal to 360 degree. Let us suppose if I'm just taking 2 common out of these two, I'm just taking 2 common out of these two angles, and I'm again further taking 2 common out of all these. So this would be nothing but angle 1 plus angle 2 plus angle 5 plus angle 6, which is equal to 360 degree divided by 2, which is nothing but 180 degree. So angle 1 plus angle 2, let's just see what is angle 1 plus angle 2. It is nothing but the angle AOB plus angle 5 plus angle 6. You can see all by yourself that angle 5 plus angle 6 is nothing but the angle COD, which is nothing but is equal to 180 degrees. So this is what we have to prove over here. So in the similar manner, proceeding like in the similar manner, in place of angle 1 I can just write angle 8, in place of angle 2 we can just write angle 3, in place of angle 5 we can just write angle 4. In the similar manner, if I'll proceed further, I can prove the second part as well, that angle AOD is plus the angle of AOD plus angle B of C is nothing but is equal to 180 degrees. So let us suppose if I'm just writing it over here in the similar manner, similarly we can prove that the angle AOD plus the angle BOC is nothing but is equal to 180 degree, which is nothing but our answer, or we can say that hence proved the theorem, hence proved this particular fact that the opposite sides of the quadrilateral circumscribing a circle subtend supplementary angle at the center of the circle.